Module 6, Lesson 6, Describing the Center of a Distribution Using the Mean. So we're going to be looking at the center of a data set, and we're going to be introduced to what is known as the mean or an average. So I can describe the center of a data distribution using a fair share value called the mean. And when we think about the mean, we're thinking about the idea that every group is going to get their fair share, this mathematical fair share, and we call that the mean. I can show and explain how to find the mean mathematically. We're going to do it with some manipulatives and move towards a mathematical application. So we're once again on step 3 here. We are summarizing data by finding the mean. So if you'll remember back in lesson 3, Robert was a 6th grader at Roosevelt Middle School, and he investigated the number of hours of sleep 6th grade students get on school nights. Today he's making a short report to the class on his investigation. And here's his report. He says, I took a survey of 29 6th graders asking them how many hours of sleep per night do you usually get when you have school the next day. The first thing I had to do was organize the data. I did this by drawing a dot plot. Looking at the dot plot, I would say that a typical amount of sleep is 8 or 9 hours. So he has presented his data collection project here, and he has made the analysis. He has said typical is 8 or 9 hours. Looking at the dot plot, what would you say is the typical number of hours of sleep 6th grade students get when they have school the next day? So take a look and see if you agree with Robert or if you disagree with Robert. And I would agree that the typical amount of sleep is around 8 or 9 hours because that's what most students said. And these values are kind of in the middle. What we have here is a description of the center of the data. Where is the middle of the data? So looking at the dot plot, how would you describe how the data points are spread out compared to the center? So if we're saying that the center is right around here, how do we describe what's happening outside of the center? Well, the data points are spread out from the center by about 3 or 4 hours in each direction. I'm about 3 hours this way. I'm about 3 hours this way. This is a description of the spread of the data. How spread out is the data? Looking at the dot plot, how would you describe the shape of the distribution? And this goes back to lesson 4. Well, if we draw kind of the outline here, well, we have kind of a mound shape. And if this is our center, it looks symmetric. So the shape of the distribution is mound-shaped, and it's approximately symmetric. We have about the same amount of data on both sides of the center. So here we have a description of the distribution of the data. So we have looked at a measure of center, or a description of the center. We have looked at the spread, and we have looked at the distribution. So looking at the dot plot and thinking about Robert's report, try to explain how Robert is thinking about the center. We're trying to take his summary and kind of put it in our own words. Well, when coming up with a typical value to describe the center, in other words, when I try to describe the center, I see Robert is drawn to the center. And by center, these are the 2 responses that had the most answers, and it is in the middle. So he's drawn to the data point that occurs most often, which we call the mode, or to the middle values. Now, Michelle is Robert's classmate. She liked his report, but she has a really different thought about determining the center of the number of hours of sleep. Her idea is to even out or fairly share the data in order to determine a typical or center value. So we're going to explore this evening out or this fairly sharing. So Michelle's looking for a more precise mathematical answer. What do you think she means by evening out the data? Pause the video and think about that for a minute. What do you think she means when she says, I want to even out the data? So we're going to try this out using, you could use linking cubes if you have them, or something else that you can move around. I've got a video I'm going to show you. I used paper clips. You need something that's small enough that you can have plenty of them and you can rearrange them, move them around. And we're going to step away from the example and the exercises that are in the math workbook. I rewrote this section of the lesson so that the numbers were smaller and easier to work on at home. So there are 3 students. They each have different numbers of pets. One student has 7 pets, another has 3 pets, and the last has 5 pets. So here are the steps you need to follow. Make groups of an item, for example, paper clips, linking cubes, pencils, pens, crayons, according to the information in the problem. We're going to have one group of 7 for 7 pets, one group of 3 for 3 pets, and one group of 5 for 5 pets. Now we're going to keep it in 3 groups, and we're going to move the objects around until each group has the same number of objects. So go ahead and try this out, and then watch the video that I made of me doing.
All right, so we are looking at this mathematical situation here where we have been given some information. We've got one person that has 7 pets, and we've got another person that has 3 pets, and we've got a third person that has 5 pets. And what we're trying to do here is take a look at the idea of a fair share. Now, in real life, we would never do this. We would never take someone's pets and say, okay, you have too many, we're going to take your pets, and we're going to give away your pets to be with this person. But what we're doing here is thinking about a mathematical concept of what does it mean for each person mathematically to have a fair share. So what we're doing is we're going to redistribute the pets so that each of these groups has the same number of pets. Now, there are many different ways you can do this. But what I'm doing is I'm going to look and say, well, I've got 7 here, and I've got 3 here, and I've got 5 here. So I could take one pet from the person that has 5 and give it to the person who has 3. So now I've got 2 people that have 4 pets, and I've got one person that has 7. So I could take one pet from the person that has 7 and give it to this person. Now I've got 6 pets, 5 pets, and 4 pets. If I take one more from this person here, person number 1 who now has 6, and I give it to this person on the end, now I've got 5 pets, 5 pets, and 5 pets. So each person has an equal number of pets, a fair share of the pets. Remember, this is a mathematical concept, a fair share of the pets. So another way that I could look at this, or think of this, is that what we do is we put all the pets over here, and we have 3 people over here, and each one of them is going to get pets. We're going to hand out the pets, and each person is going to get the same number of pets. Kind of like when we pick teams, when we play a game. You've got your captains, and each person picks, and we have fair or equal teams. So person number 1 is going to get a pet, and person number 2, and person number 3. Person number 1, person number 2, and person number 3. And person number 1, and person number 2, and person number 3. And 1, 2, and 3. And 1, 2, and 3. And we have the same result. Each person is going to have 5 pets. Now, I like this second method a little bit more because it matches more what we do mathematically. When it comes time to find a fair share in math or to find the mean, we add everything together and say this is how much we have, and then we divide it amongst the different groups. In this case, we have 3 people. And so each of them is going to get an equal share. So we added up and we had 15 pets, and we divided it into 3 groups so that we had 5 in each group. However, the result is exactly the same as if we did what we started out with. We had 7 pets, 3 pets, and 5 pets, and we took and distributed the pets equally so that there was a fair share.
So Michelle suggested evening out the data or fairly sharing to find a more precise mathematical description of the center. Now we're back to thinking about Robert and the sleep. When we move the cubes around to make all of the groups equal, we evened out the data or we fairly shared. And when I say the cubes, I'm talking about the paper clips that you just saw in the video. So evening out the data for fairly sharing can be described as giving each group an equal amount. This is why the I can statement for the lesson talks about finding a fair share value. In math, fair means equal. That's a really important concept. In math, when we talk about fair, we're talking about equal. We call this fair share the mean. So to find the mean of our experiment without using the cubes, we would total the number of pets. 7 plus 3 plus 5 gives us 15 pets. We would divide the number of pets among the total number of students. This was a student, this was a student, and this was a student. So we take our 15 pets, we divide it amongst 3 people, and we find that each person would get 5 pets. We call this value 5 is the mean. So pause for a moment and reflect upon this question. What would happen if the student that had 3 pets suddenly remembered to count their fish? Oh, I forgot, I've got fish. I don't have 3 pets, I have 6 pets. What would happen to the mean in that case? Well, what that would mean is that there are even more pets to be shared. So each person is going to get 1 more pet. There were 15 pets, but now there's 18 pets. And if I've got 3 people, each one of them is going to get another one of the pets. So the mean would increase to 6. All right, so moving more back into what was in the math workbook here, and looking more at a visual model, we had a very tactile, concrete model there. We could move the paper clips around. We're going to look at this more as a visual or representational. So suppose that Robert asked 5 6th graders how many pets each had. Their responses were 2, 6, 2, 4, and 1. And you can see that he has showed the data with cubes. Or we could use paper clips like my example. So here is 1 pet, here is 2 pets, here's 2 pets, here's 4 pets, and here is 6 pets. Now if we take a look at the same information on a dot plot, we have this dot plot over on this side. We have 1 person that has 1 pet, we have 2 people that have 2 pets, 1 person that has 4 pets, and 1 person that has 6 pets. So do the stacks of cubes match the dot plot representation? Well, I've got 1 that is 1, and 2 that are 2, 2 that are 2, 1 that is 4, and 1 that is 6. Yes, they match. They look very nice. So Robert wants to illustrate Michelle's fair share method using a dot plot. So he drew the following dot plot and said that it represents the result of the student with 6 pets sharing 1 of her pets with a student who has 1 pet. So notice that in our dot plot we no longer have the 6 and the 1. Well, the student who had 6 pets gave away 1 of their pets to the person who had 1 pet. So the person who had 1 pet now has 2 pets, and the person who had 6 pets now has 5 pets. And if we take a look at what happened in our cubes, you'll notice that our tallest stack is no longer 6, it is 5. The person who had 6 took their top cube and gave it to the person who had 1 cube. So looking again more carefully at what he did, you can see we've got the arrows here. We started out with 1 pet, but now we have 2 because the person who had 6 gave away one of theirs. The person who had 1 pet now has 2 pets. The person who had 6 pets now has 5 pets. The total number of pets has not changed. It is still 15 pets. What has changed is how they are distributed, how many each person has. So the question is the new dot plot correct? Well, the dot plot is correct. We've already looked and said the person with 6 gave away one of theirs, so they only have 5. And the person who had 1 now has 2. We've already looked at the stacks of cubes. I've done all of this already. Now, the goal is to have fair share. Does everyone have the same number of pets yet? And the answer to that question is no. No, they do not. All right, so looking at the exercises, and this is back in your math workbook here. So Robert does a fair share step by having the student with 5 pets share one of her pets with one of the students. So pause here and draw what the new stack of cubes is going to look like. And draw the dot plot that shows what happens. So we are continuing on each of these next problems to move towards each person having the same number of pets, having a fair share. So the person with 5 gave one away to a person that had 2. And that person now has 3. So it's probably better if I draw an arrow and circle this. This cube right here came from this spot over here. And the dot plot is going to be similar. We no longer have a student that had 5 pets because they gave away one of theirs so that a person had 3 pets. Remember, we had 3 people that had 2 pets. Well, now one of them has 3 pets. All right, so taking a look at exercise 8, Robert does another fair share step by having one of the students who has 4 pets. They've got 4 pets. They're going to share 1 pet with one of the students who has 2 pets. So what would the cubes look like at this point? Well, they would look like this. So there used to be 4 cubes here, and there used to be 2 cubes here, but this cube right here, it moved. So a student that had 2 cubes now has 3 cubes. And our dot plot is going to have a similar change. Someone's going to go from having 2 pets to having 3 pets, and someone's going to go from having 4 pets to having 3 pets. So we just doubled, well, didn't double, we added 2 more people that have 3 pets. All right, taking a look at exercise 9. Robert finally does a final fair share step by having the student who has 4 pets share 1 pet with the student who has 2 pets. So we've got 1 person left who's got 4. We've got 1 person left who's got 2. Everyone else has 3. If the person that has 4 shares 1 with the person who has 2, then they'll both have 3. So you'll remember we had a 4 over here and we had a 2 over here. Well, this cube right here came from the 4 and joined the 2. So now we have 3 for everyone. And this is what it looks like on the dot plot. So explain in your own words why the final representations using cubes and a dot plot show that the mean number of pets owned by the 5 students is 3 pets. So pause and think about that for a second. How does that final representation show that everyone has 3? Well, the sharing method produces 3 pets for each of the 5 students. The cubes show that after sharing, each student has a fair share of 3 pets. Fair share, an equal share. Each of them has 3 pets. The dot plot representation should have all of the data points at the same point on the number line, the mean. That's kind of a cool concept here. I think I'll bracket it. We know that we have found the mean when all of the points on our dot plot are in the same spot. In this problem, the mean number of pets is 3 for these 5 students. So there should be 5 dots above 3 on the horizontal scale. And there was. So the fair share method. Students were to have the same data value. This common value is the mean of the data. When we ask how many pets does each of you have, we want them all to have the same value. That is the mean. The mean means everyone has an equal amount. Mathematically, the fair share mean comes from finding the total of all the data values and dividing the total by the number of data points. So we add it all up, so the total of all the data values, and we divide by the total number of data points. So if I add it all up and I've got 25, and that's in 5 different groups, I can find a mean of 5. Add everything up and divide by how many numbers you added up. Or another way of thinking of it, and I talked about this in the video, put everything into one big pile and then share it so everyone has the same amount. So taking a look at the I can statements, I can describe the center of a data distribution using a fair share value. Remember, fair share means equal. If everyone had an equal amount, what would they have? And we call that the mean. The amount that everyone would have if it was equally shared is the mean. And hopefully you can show and explain how to find the mean mathematically. You could move some paper clips around or some other objects. You could show adding everything together and then dividing it up. So that concludes Module 6, Lesson 6. Finding the fair share value known as the mean. So make sure that you know what you're doing, work on your problem sets, ask your teachers if you need help.